Water content or moisture content is the quantity of water contained in a material, such as soil, rock, ceramics, fruit, or wood. Water content is used in a wide range of scientific and technical areas, and is expressed as a ratio, which can range from 0 to the value of the material's porosity at saturation. It can be given on a volumetric or mass basis. Definitions: volumetric water content, I, is defined mathematically as where is the volume of water and is the total volume. Gravimetric water content is expressed by mass as follows. Where is the mass of water and is the bulk mass. The bulk mass is taken as the total mass, except for geotechnical and soil science applications where oven-dried soil is conventionally used instead of. To convert gravimetric water content to volumetric water, multiply the gravimetric water content by the bulk-specific gravity of the material. In soil mechanics and petroleum engineering, the term water saturation or degree of saturation is used, defined as where is the porosity and is the volume of void or pore space. Values of SW can range from 0 to 1. In reality, SW never reaches 0 or 1, these are idealizations for engineering use. The normalized water content is a dimensionless value defined by van Genichten as where is the volumetric water content. Is the residual water content, defined as the water content for which the gradient becomes 0. And, is the saturated water content, which is equivalent to porosity. Measurement, direct methods. Water content can be directly measured using a known volume of the material, and a drying oven. Volumetric water content, I, is calculated using where, and are the masses of the sample before and after drying in the oven. Is the density of water. And, is the volume of the sample before drying the sample. For materials that change in volume with water content, such as coal, the water content, U, is expressed in terms of the mass of water per unit mass of the moist specimen. However, geotechnics requires the moisture content to be expressed as a percentage of the sample's dry weight, that is a percent moisture content equals Wh, 100%, where. For wood, the convention is to report moisture contents on oven-dry basis. In wood drying, this is an important concept. Laboratory methods. Other methods that determine water content of a sample include chemical titrations, determining mass loss on heating, or after freeze drying. In the food industry, the Dean-Stark method is also commonly used. From the Annual Book of ASTM Standards, the total evaporable moisture content in aggregate can be calculated with the formula. Where is the fraction of total evaporable moisture content of sample, is the mass of the original sample, and is mass of dried sample. Geophysical methods. There are several geophysical methods available that can approximate in situ soil water content. These methods include time domain reflectometry, neutron probe, frequency domain sensor, capacitance probe, amplitude domain reflectometry, electrical resistivity tomography, ground penetrating radar, and others that are sensitive to the physical properties of water. Geophysical sensors are often used to monitor soil moisture continuously in agricultural and scientific applications. Satellite remote sensing method. Satellite microwave remote sensing is used to estimate soil moisture based on the large contrast between the dielectric properties of wet and dry soil. The microwave radiation is not sensitive to atmospheric variables, and can penetrate through clouds. Also, microwave signal can penetrate, to a certain extent, the vegetation canopy and retrieve information from ground surface. 1. The data from microwave remote sensing satellites such as WindSat, AMSRE, RADARSAT, ERS-1-2, and TOP-ASCAT are used to estimate surface soil moisture. 2. Classification and uses. Moisture may be present as adsorbed moisture at internal surfaces and as capillary condensed water in small pores. At low relative humidities, moisture consists mainly of adsorbed water. At higher relative humidities, liquid water becomes more and more important, depending on the pore size. In wood-based materials, however, almost all water is adsorbed at humidities below 98% RH. In biological applications there can also be a distinction between phys-adsorbed water and free water, the phys-adsorbed water being that closely associated with and relatively difficult to remove from a biological material. The method used to determine water content may affect whether water present in this form is accounted for. For a better indication of free and bound water, the water activity of a material should be considered. Water molecules may also be present in materials closely associated with individual molecules, as water of crystallization, or as water molecules which are static components of protein's structure. Earth and agricultural sciences. In soil science, hydrology and agricultural sciences, water content has an important role for groundwater recharge, agriculture, and soil chemistry. Many recent scientific research efforts have aimed toward a predictive understanding of water content over space and time. Observations have revealed generally that spatial variance in water content tends to increase as overall wetness increases in semi-arid regions, to decrease as overall wetness increases in humid regions, and to peak under intermediate wetness conditions in temperate regions. There are 4 standard water contents that are routinely measured and used, which are described in the following table, and lastly the available water content, IA, which is equivalent to IAA per mil IFCA IPWP, which can range between 0.1 in gravel and 0.3 in peat. Agriculture. When a soil becomes too dry, plant transpiration drops because the water is increasingly bound to the soil particles by suction. Below the wilting point, plants are no longer able to extract water. At this point they wilt and cease transpiring altogether. Conditions where soil is too dry to maintain reliable plant growth is referred to as agricultural drought, and is a particular focus of irrigation management. Such conditions are common in arid and semi-arid environments. Some agriculture professionals are beginning to use environmental measurements such as soil moisture to schedule irrigation. This method is referred to as smart irrigation or soil cultivation. Groundwater. In saturated groundwater aquifers, all available pore spaces are filled with water. Above a capillary fringe, pore spaces have air in them too. Most soils have a water content less than porosity, which is the definition of unsaturated conditions, and they make up the subject of vadose hydrogeology. The capillary fringe of the water table is the dividing line between saturated and unsaturated conditions. Water content in the capillary fringe decreases with increasing distance above the phreatic surface. One of the main complications which arises in studying the vadose zone, is the fact that the unsaturated hydraulic conductivity is a function of the water content of the material. As a material dries out, the connected wet pathways through the media become smaller, the hydraulic conductivity decreasing with lower water content in a very non-linear fashion. A water retention curve is the relationship between volumetric water content and the water potential of the porous medium. It is characteristic for different types of porous medium. Due to hysteresis, different wetting and drying curves may be distinguished. See also, humidity, water content in air, moisture, moisture analysis, soil moisture sensors, water activity, water retention curve, references. Further reading, Field Estimation of Soil Water Content, A Practical Guide to Methods, Instrumentation and Sensor Technology, Vienna, Austria, International Atomic Energy Agency, 2008, PA 131, ISNA 1018-5518, IAEA TCS 30A.